Okay, so hi Alvin, good to see you. Okay, so what I'm going to do is that probably with the purpose of getting you what happened here? Ah, yes, here. With the purpose of getting you on track and on the same page with regard to these basic tools that we are using, I'm going to just do a quick summary of these two games that we played, and through those sort of expand to what the greater questions are regarding social interactions and how we deal with especially environmental dilemmas, social dilemmas associated with affecting each other because of actions that are generating externalities. And we will be dealing with the idea of externalities in much more detail in the next section. So with that summary, I will try to do that in the next probably 50 minutes. And by then we will have some 10 minutes left to do the quiz at the end of the class, okay? So, so that way we can solve questions, clarify issues, concepts, and the like, and then we should be able to go ahead with the quiz. But to me, the purpose of the quiz is, it's not an ambush, but it's a testing of how we are all in the same page, okay? So with this, a question? Do you have a question?
Yeah, do we know the format of the quiz?
I'm trying to putting it together here. Oh. So it's I'm struggling still with Moodle, but I don't want to take risks, and I have it in the Zoom poll in the polls. So we'll see. Okay. Good. So this game in particular, it's called an invisible hand game because it's basically a game in which self-interest and basic self-maximizing or maximization of self revenues or material gains, self-oriented preferences will guide both players towards an outcome in which they both are better off. This is key. This is like similar in a way to driving on your right in certain countries and driving on your left in other countries. Although it involves a little bit more interesting features in this particular game on whether you want to plant rice or cassava. And this game we played, and you remember the results. Most of you ended up then choosing bottom as your dominant strategy or best response, and choosing left for those of you who were the column players, and therefore you ended up winning 4 and 4 each of you. And you saw the data last time, and it was pretty clear. However, in this game, in which we don't have that dimension of coordination as clear as in this game, in the planting cassava and Bala, in this new game, our same two characters, Bala and Anil, need to decide over the pest control. And this is a good example of an externality that involves a social dilemma in environmental terms, because they both would be better off by using the integrated pest management. We can see that in the game. They both would be better if they end up choosing IPC as their strategy. But there are incentives for both of them to deviate from that. So the incentives to deviate are key. Here, there are no incentives to deviate from this point, which we can call an equilibrium, right? Because if Anil wants to move from cassava to rice, Anil's earnings go down from 4 to 1. And the same if Bala wanted to move from rice to cassava, Bala's earnings go from 4 to 1. So they have, neither of them have incentives to move away from this equilibrium. And this is why we call this an equilibrium, because there are no incentives to get out of there. However, here, we can agree that both players could be better off in 3-3, and yet they both have incentives to deviate from that, right? Because Anil could earn 4 instead of 3, by shifting away from IPC to the exterminator. And in the same way, Bala would be better off moving from 3 to 4, and therefore Bala would be better off shifting away from IPC to terminator. And if both of them respond to that dominant strategy, then they will end up in this 2-2, in which they are both worse off. Both of them end up worse off than with 3-3. Okay, and that's the basic. So what I want to get clear here is that we get this basic gym routine, I call it like that, in which we learn how we analyze the games. And in these games, we figure out whether a game has a dominant strategy or not, if it is a Nash strategy or not, and whether the game has 1 or 2 or more equilibrium. Okay, so that's the purpose of this routine that we want to do. And in the book, you can find one way of doing it, and I can show you more ways here in that sense. So let's do with that gym routine both of these. So here's what I'm going to do. Clearly, I mean, very simple. I'm going to think first as if I am Anil, and I'm going to evaluate all my possible strategies. So Anil has 2 strategies: to plant cassava or to plant rice. And I'm going to evaluate those 2 strategies against the different possibilities that Bala has in front of him, which is also to plant cassava or rice. So I'm going to start with rice, and with rice, or if I do it here, it's probably easier, it's a bit bigger, the font. With rice, notice I can choose between top and bottom, and 4 is better than 1. So I just underlined 4. Now I'm going to see what if Bala chooses right instead of left. If Bala chooses right, then I'm going to compare between $2 and $3. And between 2 and 3, I have 3, because I'm better off with 3. By now, I have discovered that Anil has a best response function that says, if Bala chooses left, I should play bottom. If Bala chooses right, I should play bottom. And therefore, because in both cases, I have bottom as a best response function against the different decisions of Bala, then Anil's dominant strategy is to play bottom or to plant cassava. But so far, I have analyzed only Anil. Now I'm going to go to Bala. So let's do that with another color. So let me change here, the color to green. And now I'm going to think about, if I were Bala, what would I do? Now Bala has to choose between rice and cassava, or left and right. So Bala is going to start first evaluating whether Anil chooses top. If Anil chooses top, between 2 and 3, Bala prefers $3 and therefore should play left. Now let's see what happens if Anil chooses bottom. Now Bala needs to compare 4 or 1 and definitely prefers 4. And now notice I have underlined in the same cell 2 values, and therefore I can say that this is a Nash equilibrium of the game. Every time that I find a cell in which 2 values are underlined or selected as best response to the other's actions, and if all those values in that cell are underlined, therefore I can assure that that's an equilibrium. And therefore 4-4, that is Anil plants cassava and Bala plants rice, it's a Nash equilibrium. And it's the result of a dominant strategy in the case of Bala to plant rice, and in the case of Anil to plant cassava. Okay? Now I'm going to use that same gym routine to the game in the right. So notice, in the game in the left, there are no environmental externalities. In the plane in the right is when we deal with externalities associated with environment. And basically, you know this story. We talked about it last class and you read. The use of pesticide in one farm affects the other farm's well-being because the pesticide flows, or there's runoffs to the land or the soils or the water to the neighbor. Okay? So I'm going to do exactly the same routine. Now, again, I'm going to start with red here to think as if I am this Anil guy. Anil guy is going to evaluate first if Bala plays left between 3 and 4. Anil prefers 4. Now, if Bala plays right between 1 and 2, again, in this case, Anil prefers bottom because 2 is better than 1. Those blue playoffs. Now I'm going to change the color and I'm going to do this in the following way. So now we're going to think from Bala's standpoint. So I'm going to think about Bala's well-being, and Bala is going to start thinking, what if Anil plays top between 3 and 4? Bala prefers 4. Now, what if Anil plays bottom between 1 and 2? 2 is better than 1. Bala prefers to play right or Terminator and earns those $2. And now we have, again, in this particular case, one Nash equilibrium, which is play Terminator, Terminator. And they end up in a social dilemma because they are both overusing this pesticide and they are both polluting each other and they are both trapped in this problem. So this would be an example of what you have read as the classical tragedy of the commons. In this case, the commons it's a negative externality. Okay. So we have done this gene routine here. Now I want you to think once again, as you did a couple classes ago that I told you in this first Zoom poll about your previous learning of game theory. I want you to think about this particular game. Okay. So that's the game. And those are the payoffs. And based on what I just did, this is not the quiz. This is just like a warm-up non-grade quiz towards the quiz that we're going to have at the end of the class. I want you to then answer. Whoops, no, wait. No, there's no poll. So I'm going to do it just with you guys. Where is it? Hold a second, something's going on here. No, I lost it. Okay, so let's do it here. So anyone wants to start doing the gym routine that I just did with me by telling me how would you do the same analysis for this game and see if there are best responses, dominant strategies, and so on? Anyone wants to volunteer? Should I choose from the list? Let's do it the following way. So, Tammy, give me the last digit of your ID number, the UMass ID number, the last digit only.
4.
4. So it's 1, 2, 3, 4. That's you. At least in the order that I see you here in the screens. So you're the fourth person that I'm seeing in the screen. So let's go with you, Tammy. Where do you want to start? Analyzing from the standpoint of the row player or the column player? Choose one of them, just one of them.
The column player.
Okay, so you want to analyze the column player. We were doing that with green, so let's stick with green. So we're going to start analyzing column player. So tell me, what should I do with my pencil here?
Okay, so for the column player, if they were to choose X, so the first column, the second, and the row player was to choose X.
Okay, so you want to start analyzing what if the row player chooses X? Okay.
Yes.
Okay.
So then the column player would choose 3 because the 3 is more than 2.
Anyone wants to jump in and help Tammy with that? Robert?
Well, I think you choose X because you have more overall, like, you know, with the matrix, you'd be able to get more money. Over, like, as in, like, on average, you'd be making more money.
So Tammy is saying that column players should choose X instead of Y because she's looking at.
Oh no! I meant that. Sorry. So if they were choosing X, so if the column player, sorry, if the row player was choosing X, the column player should be choosing Y because 3 is more than 2.
So you were almost perfect there, but there was one minor but crucial detail. Anyone spotted that?
Yeah,
Thomas,
it's
go ahead,
5.
Thomas.
It's 5 instead of 3.
So,
So
why
they get to choose
are you
between 2 and
comparing,
5.
Thomas, why are you comparing the 5 against the 2 and Tammy was comparing the 3 against the 2?
Because the second value is the column player's
Payoffs.
choice. Yes.
Okay. So that's important. So Tammy was correct in saying, okay, I'm going to analyze first, what if the row player chooses X? Then I'm going to be comparing these two scenarios, right? But notice, and here's the bottom line of the end, notice column player needs to look at these numbers, the numbers in the right, because the payoffs to the column player are the right numbers in each cell, whereas the left numbers in the cell are the payoffs to the row player, okay? So back to that, if we combine both Tammy and Thomas's together, if they were working as a team, you will find correctly that 5 is better than 3, and I'm going to be underlining the 5. Okay? Now, Tammy, give me a number from 1 to 10.
8.
8. So 1, 2, 3, 4, 5, 6, 7, 8. Liang Fan. Liang, are you there? Liang is not present.
In the chat.
Okay, so let's do another 8. 1, 2, 3, 4, 5, 6, 7, 8. Harrison, are you there? Nope.
I'll volunteer to do it.
Okay, Jesse, go ahead.
Am I
Jesse,
doing the
let's
row?
do-
Am I doing the row or the column?
So,
Or am I just doing the Y?
Tammy suggested we started with the column player, and we're not done yet. We're halfway. So Tammy started by analyzing what should the column player do if the row player had chosen X. What's next?
Okay, so if the row player chose Y,
Okay,
then the column player should choose X, right?
why?
Because 3 is greater than 1.
Exactly. So now I underlined 3. Now, Jesse, does that mean that the column player has a dominant strategy?
No, technically,
Why?
because X is still making more money than him. It's just that the payoff for if he chose Y would be less. But X is either way, either one they choose, he still end up either getting equal or more money than him.
Yeah. So in a nutshell, the column player doesn't have a dominant strategy because he would not be always better by choosing always X or always Y. Y would be good if the row player had chosen X, but X would be good if the row player had chosen X. Okay, so we're there. So now we have checked the column player. Now I'm going to go to the row player, and we were doing that, I think, with the red color. So let's go with red. And Jesse, give me one number from 1 to 10.
7.
So 1, 2, 3, 4, 5, 6, 7. Robert, are you there?
I'm sorry. Yeah, I'm here. Hi.
Okay, good. So now we are going to do the row player. Okay, so we're going to do this row player. So what should I do with my pencil here?
Let's think about it. So the thing about like either X or Y is like, X, you're more sure of it. Y, you're really taking a risk because Y, you can get the 3. Wait, yeah, Y, you can get the 5, but you can also get the 1. Whereas the X, you kind of 2 or 3.
No, but why are you comparing the 5 to 1? That confuses me a little bit.
I'm just thinking like, as in like that combined versus the 2 to 3. If you're thinking about how can I make money, like the question is like, you're sort of risking a lot there to potentially.
I'm thinking if you could do the gym routine that I was doing before.
All right.
Just the same way that Tammy started doing. She started in the green drawings. She said, if I am a column player, let's see what should I do if row player were to play X, and then if row player was to play Y. Let's do the same now for the row player.
Yeah, if I were X, if they said X, I would, I mean, I would do Y because that would be a better benefit to me by
So
a
what
dollar.
numbers are you comparing in that case?
I'm comparing the 2 to the 3 for the row player to have the $2 or the $3 with the column player.
No. Anyone wants to help that?
Yeah, I can help with that. You'd be
Go
looking
ahead,
at
Chris.
you'd
Go
be
ahead,
looking at
Chris.
the 2 and the 5,
Why?
because it's the column player, so it's going down instead of across.
Yeah, and so did you get that, Robert?
Yeah, no, I got it. I'm sorry.
Exactly.
I think I was just
So
looking.
the row player has to look at these numbers. These are the numbers that the row player is paying attention to, okay? So with those numbers,
I mean, I was.
so with those numbers, what we're saying is between this 2 and this 5, 5 is better.
Yeah,
And notice
definitely.
I just underlined 2 values in the same cell. That means that for now, we have here one Nash equilibrium, okay?
Yep.
Okay?
Okay, yep, that works.
Great. Now, question for you, Robert.
Mhm.
Does that mean that the row player has a dominant strategy, or we are not done yet?
We're not done because we don't know whether they got an X or Y. So obviously, if you knew the column player had an X, then you could have a dominant strategy by virtue of taking the 5
Okay.
every single
So
time.
to check that, and you're right, to check that, now we need to think, I'm sorry, because I should be doing this with the oops, wait, with the red color, wait here, with the red color here. Now, if the column player played Y, now what should the row player do? If the column player was to play Y, what should the row player do?
Definitely hit X.
Exactly, because between 3 and 1, 3 is better. So what else did we find in this game?
That's also a Nash.
This is another Nash equilibrium, right? So we have a game where there are 2 Nash equilibria. And secondly, this game doesn't have a dominant strategy for neither of the players, right? You see?
Yep. Yep.
Now, finally, and here's a recap of the 2 previous games. And this is important that we are clear on this. In this particular game of the invisible hand, the Nash equilibrium coincides with the social optimum, which is 4-4. And this is why it's called the invisible hand game. Just each of the players pursuing her own interest will end up in a situation in which all the society is better off. In this case, that's not the case. Because what is better for society, these 3 and 3, is not the case of a Nash equilibrium, because we already saw what the Nash equilibrium here is, which is this 2-2. And now in this third game that we just did, you saw that there are no dominant strategies for the players. There are no, the best response for each player is dependent on what the other player does. And we have 2 Nash equilibria. Having said that, these both, and let me erase all this scribbling here. In this case, notice both of these and these are socially optimum. We produce the biggest pie, which is $8. Because in the other 2, we produce either $4 or $2. 2 and 2 and 1 and 1. So 5 and 3 and 3 and 5 are both socially optimum, and they coincide both with Nash equilibria. But now the question is, how would society guide people to either end up in the 5-3 or the 3-5? And the reason I like to show you this game is because if you were the row player, you would definitely prefer this case here, the 5-3. But if you were the column player, you would like this here, 3-5. Now, how do we decide as society who should be row and who should be column? And that gets complicated, right? And this is, again, one good reason I wanted to add this extra game to think about the problem of the political economy of these games.
Quick question. So I didn't understand
Yes.
why it was called an equilibrium if technically that outcome can't be made, right? If they both choose Y.
Yeah, so that's a good question. If I understood, Jesse, you want to know why both are equilibrium and why they're called equilibrium?
Yeah, technically it's not equilibrium, right? Because if they both choose Y, they both get $1, right?
Exactly. And notice first, let me do it in reverse by saying, how should we evaluate if this particular case, the 1-1, is an equilibrium or not? Remember, the notion of equilibrium means that you have an incentive to deviate from there. So let's suppose for a reason that I tell both players, okay, you should play Y, just because I imagine it's a good idea. Play Y, both of you. Now the two players have incentives to get out of there? Yes. Notice, the row player should get out of this 1 and try to get this 5. So the column player, sorry, I'm mixing things here. Let me get it again with the color idea. So suppose I tell these two players to stay there. Now, the row player first, this row player has an incentive to get out of there? Yes. If that row player was to play X instead of Y, it would go from 1 to this 3, and this 3 is better than 1.
I see what you mean.
Think
So
of the column player. Does the column player has an incentive to deviate from there? Yes,
yeah.
Because this 1 is worse than this 3, and the column player would prefer to be earning 3. So they have incentives to get out of there, right?
So it's not the fact that they both, it's not the numbers that are the 5 and 3 and the 3 and 5. It's the fact that they chose against that and met at 1 and 1 is what the equilibrium is.
Yeah, the idea of equilibrium is if you're in a situation in which you don't have incentives to get out of there, to move away from there, you are in an equilibrium. And that's not the case in 1-1. In 1-1, both players have an incentive to get out of there by playing, instead of Y, playing X, for example. Now, again, does that mean then that if they both play, and this is a good question in that case, if they were playing both X, is this XX that gives them $2 and $2? Is that an equilibrium? Yes or no? What do you think?
Yes.
So some of people are nodding, and other people are saying no, and others are saying yes. Anyone wants to show me why this 2-2 is or not an equilibrium? Who wants to try?
Yeah, I can.
Go ahead, Thomas.
It's not, because both players are still incentivized to switch.
Whoops.
Like
Yeah,
right now, the row player would switch to Y because they'd get 5 instead of 2. And the column player.
So the row player wants to move away from these 2 and try to get this 5 on my moving to X. And what about the column player?
What was the Nash equilibrium you were saying?
What's that?
What's Nash equilibrium then?
Nash equilibrium means that both players end up in a situation, or all players end up in a situation in which their best response to the others' responses are to stay where they are. If that happens, that's a Nash equilibrium.
Okay, so that was what I was asking. I know that equilibrium is when they're both like they do the same thing.
But in the case of Nash, it means that everybody is in the same situation in which nobody has an incentive to deviate. Because you could have the case that one player doesn't have an incentive to get out of there, but the other player does have an incentive to get out of there.
In this example you're showing us is a Nash equilibrium?
So let me throw the question back to you. In this game, which are the Nash equilibria?
both of them at
Which
Y.
ones?
Or so if row picked Y, that would be his best choice, right? And if column chose Y, that would be their best choice as well.
Yeah, exactly. I mean, between 2 and 5, row prefers this 5. Between 3 and 1, row prefers this 3. And in the case of the column player, between 2 and 5, column player prefers this 5. And between 3 and 1, the column player prefers this 3. And therefore, we have this as a Nash equilibrium and this as a Nash equilibrium.
Oh, okay, I see what you mean now. I thought it had to do with the YY, like the numbers, like 1 and 1 was the relevant number.
Yeah, I mean, it's equivalent by saying the strategies or by saying which payoffs are the result of which strategies. Let me get back here. I don't know what happened with my my camera, but I am back here. Okay. So is it clear that both of these situations here in green are both Nash equilibria and they are both socially optimum? But we are still at a point in which society needs to decide if you get to be a row player or a column player. Because if you get to be a row player, it's nice that you get those $5 instead of the 3. But if you are a column player, it's better that you get the $5 instead of the 3. So if I tell you, for example, in this game with these 2 equilibria, which player would you prefer to be? You would probably prefer to be the row player, right? But who decides who gets to be the row player? Because somebody else has to be the column player. And this is where the political economy of the problem comes. Who has the power to decide whether you are the row or the column player? So I'm going to give you stories that are popping in my mind quickly. 1, women get to be the row players just because they are women. So every time a woman and a man are going to play this game, I am going to sit the women in the row player seat. Okay? I'm going to give you another one. If I get 2 people and one of them is a white person and the other one is a black person, I'm going to put the black person in the row player seat just because I wanted to. And therefore, if you're a woman or if you're a black person, then as a row player, you always, when playing this game, are going to be earning those $5. And the other person is going to end up playing and getting those $3. Right? Further, what if I impose a rule that the row player decides which of the 2 equilibria you are going to be coordinating with? In other words, remember, in both cases, you can get $8 as a whole, as a society. So it can be in either place. But if the row player has more power to decide that it's going to be exactly this one, this equilibria that they're going to be end up playing, so that the row player always earns those $5 instead of the 3. How does that affect in the long run that the row players end up accumulating more and more and more income, and the column players begin to accumulate less and less and less income because somehow somebody decided that they wanted to guide this way the allocation of who gets to play what. And this that I'm saying, when you think about all kinds of environmental cases in which you have, and we will be looking at examples of that kind later on, in which one of the players is imposing an externality on the other one. And that externality is affecting both payoffs. But the externality is imposed in one direction instead of bidirectional. So one of the players is imposing the externality on the other one. It's going to matter a lot which position you are at. In the case that we did the experiment with you guys, you basically ended up being randomly chosen as a column player or a row player. But I could have chosen any other criteria. I could have said, give me your height, and I'm going to put the taller people as row players and the shorter people in the column players. just because I wanted to. And that's where all the problem of distributional justice and inequalities of power and inequalities in the opportunities are going to be playing such an important role in what we are doing these days in this course with respect to environmental issues. Because in many environmental situations, and it is not an exception, that probably in every one of your term paper ideas that you wrote about agriculture, deforestation, local markets, electric cars, solar energy, and the like, there's going to be asymmetries of power on who decides to be as a role player or a column player. And then remember that you have an essay coming up in which you are going to be using these tools to study a particular example based on game theoretical tools like we have been using to think about the power and the inequalities and the consequences of the strategic interdependence in the actions in the particular setting that you want to write about your term paper. Okay, so that's the wrap up of this. So let me get back to this in the idea that here, and some of you saw these movies and some didn't. If I remember in the data, many of you have seen the case of the Batman, the Dark Knight. And if things go well, let's see if I can play this clip for you, because this clip, if you saw the movie, you can watch it again. If you didn't see in the movie, you probably are going to be understanding more or less the game theoretical situation. But this is probably one of the highlight moments of this particular movie. I don't think I am going to give you much more detail on the ending of the movie if you haven't seen The Dark Knight. But let's see if this works out. So let me stop the sharing here and let's see if I can get. Okay. Yep. Let's see. I think I can go ahead here. Oops, here. Wait. So I'm going to share here the screen with this share sound optimized for video clip. And the setting is the following. The Joker is just creating chaos in the city. And he was able to guide two groups of people into two ferry boats. One group of people were prisoners that were taken out of jails and put in one ferry boat. And in the other ferry boat, he put a number of citizens, just average lawful citizens in the other ferry boat. And here I want you to think about the game theoretical situation. So let's see if this works out well. And I'm going to play the clip. This is just three minutes. And here it goes.
Hey man, that ain't right. We should be on that boat. You want to ride across with them? Be my guest.
Sir, they've stopped their engines.
Right, get on the radio. Tell them we'll come back and pick them up once we dump the scumbags.
Liberty, this is Spirit. Come in.
What the heck was that? Liberty, come in, please. This is Spirit. Come in.
Fox, there's something going on the ferries.
Get down to the engine room now.
Captain, got 100 barrels down there rigged to blow. In this.
Why would they give us the detonator to our own bomb?
Tonight, you're all going to be a part of a social experiment. Through the magic of diesel fuel and ammonium nitrate, I'm ready right now to blow you all sky high.
Liberty, come in, over. It's dead.
Anyone attempts to get off their boat, you all die.
I'm zeroing in.
Each of you has a remote. Blow up the other boat.
Force is on the ferry, but it's not the source. West. Gordon.
I have the Joker's location. Pruitt building. Assemble on the building opposite.
At midnight, I blow you all up. If, however, one of you presses the button, I'll let that boat live. So, who's it gonna be? Harvey Dent's most wanted scumbag collection, or the sweet and innocent civilians? You choose. Oh, and you might want to decide quickly, because the people on the other boat may not be quite so noble.
Stay back.
Well, now, who are you to decide? We ought to talk this over at least.
You don't all have to die. Those men had their chance.
We are not going to talk about this.
Why aren't we talking about it?
They're talking over the same exact thing on the other boat.
Let's put it to a vote.
You should probably read all your poems.
Okay, so if you saw the movie, you remember that. If you didn't see the movie, I'm not going to tell you what happened. But the critical dilemma that you're watching here is that each player depends on the actions of the other one. And now they have two options: to click the detonator or not, right? And if you click the detonator, you blow up the other boat. If you don't click the detonator, you don't blow up the other boat. But after a period of time, there's a third player who is the Joker, who is manipulating the whole thing. And he's saying, if neither of you click the button, the detonator, I'm going to click both detonators and everybody is blown up. So this is a much more complicated game. It's kind of funny because if you go into Google and look at game theory, Dark Knight, everybody's going to say that this is a classical prisoner's dilemma. It is not. First of all, because there are three players here. There's Fairy 1, Fairy 2, and the Joker. And the Joker is deciding depending on what Fairy 1 and Fairy 2 do. So that's one important thing. The other important thing that I want to introduce here is the idea that in the what we could call the preferences of these people, that is the people in either boat. And if you remember the movie, and if you haven't watched it, I recommend it. It's really interesting for this particular period of the movie, is how much is it going to matter what you care about the well-being of the others in the other boat. And of course, you have the Hollywood scenery of how to put all this together, but the bottom line is, how much is it going to matter that I'm going to click or not, depending on my own self-interest and the interest of my caring for the interest of the others in the other boat, okay? If you want to make it simple, just think that you run this experiment, but with two people, one in each boat, instead of all this number of people in each boat, because then the voting within each boat is going to complicate even further things. But I think you get the point. How much I care about my own well-being and how much I care about the well-being of the others in the other ferry boat. And in this case, it's quite asymmetric because one ferry boat is full of prisoners in jail who broke the law. And in the other one is a number of people who are not breaking the law or didn't break the law or are not paying a sentence in jail. So this asymmetry makes it even more complicated and more interesting, I think, okay? So with that, let me just go to a few more slides here of what I want to tell before we open up for the quiz, and that is the following. So let me go here and share the screen here and go here. Now, I had one more movie there that I wanted you to think about, and that's V for Vendetta, because it has some interesting scenes regarding the decision on whether to play against or in favor of each other, but at the same time, how much cares or is important that there is a superior, powerful entity that it's controlling much more of the game than what we think. And this is again the idea of the Joker playing the two players in the ferry boats, right? And this is important because this is about institutions, how institutions create overlaying or an umbrella of rules and power and norms and conventions that are going to restrict or not what the players below the umbrella are able to do. Okay, so that's important in that sense. And in V for Vendetta, there's a lot of these too, and if you haven't watched the movie and if you remember the movie or the comic book. And then there is this comic artist, this guy Will Eisner, who has written very interesting stuff, and he has this particular short story called Humans that I'm going to send you through the Moodle that I want you to read if you haven't, because it's beautiful in the sense of getting at these issues of the human nature and how humans have evolved and how they have behaved over time regarding these different difficulties on affecting one or the other situation, or your own well-being or the well-being of others. And in that, let me just leave you here with one extra game, which is the following. If you look at the game in the upper part, which we have already seen in the case of the pest control game, you remember that, and that should be here with this, let me put it here, that if both players are going to play the integrated pest management, they are both going to earn these $3. And altogether, those $6 is the better situation for society. Now, let me transform that game a little bit with the game below. Notice this, if I put it this way, this 3 is the same, this 3 is the same, this 1, this 1, this 2, this 2. But I'm going to change this 4 to this 8. And I want you to think what has changed in this game. Because if we do the gym routine that I was telling you before, in the sense of what's the Nash equilibrium, what are the best dominant strategies for these players, we are going to find some interesting similar things than the original game, namely that between 3 and 8, the role player prefers 8, between 1 and 2, that person prefers 2. The column player between 3 and 8 prefers this 8, and between 1 and 2 prefers this 2. So we have here a Nash equilibrium for this game. But now this 3-3 is not anymore the social optimum of the game. It was the case in the previous game. This was the social optimum, and this was the Nash equilibrium, right? But now the social optimum is going to be either 8-1 or 1-8, because there we produce a pie of $9, not of 6, not of 4, but of 9. And here again comes an open big question about social efficiency, because the Nash strategy or the dominant strategies for the players is to be away from the integrated pest management and go back to the pesticide if they were going to pursue their self-interest. But if we think of social efficiency, if we think of what maximizes the society's well-being, is going to be either 1-8 or 8-1. But that is going to involve huge inequalities. So if you were a social planner that you wanted to generate a result that maximizes the well-being of society, and you measure that as the sum of the payoffs of both players, you would like, in this case, that one of the players uses the pesticide and the other player doesn't, so that the player who uses the pesticide gets a lot of money, $8, and the other player is going to get $1, and you produce $9. But then again, yes, that's the social efficient case, but who decides who gets to use the exterminator and who gets to use the integrated pest management and receive all the harm, the damages from the externality imposed by the other who used the pesticide and imposed those costs into me, and that person got to earn a lot of money, those $8, because the social setting, the rules of the game, the legislation, the incentives, you name it, allow that person to use the exterminator and earn those $8. And yes, 8 plus 1 is better than any other scenario. But how is that going to fare in terms of inequalities, but also in terms of who gets to decide what to use or to choose? So depending on the economic system that you are, we're going to have different scenarios for this, okay? So that is going to be involved in the ideas of justice and inequalities that we're going to start working next week. But I wanted to lay this out there because we're going to go back to come back to this place, to these games, to understand that. Let me just give you, in the 2-3 minutes that I have before we get to 3:30 and run the quiz, how, as you read in the second half of the chapter 4, the idea of trust and reciprocity and prosocial behavior is going to play some interesting elements into our analysis. And in particular, if you remember this game that you were playing, how come if in treatment 2, in that second game that you were playing here, this second game that you were playing, because remember, the Nash equilibrium is that both end up in 2-2, that is playing bottom and right. How come some of you were able to choose to play sometimes away from that best response? And some of you, at some point in some of the rounds, even though your best strategy was, remember, as we are going here, if you think between top and bottom, you would be better off playing bottom. Sometimes you chose to play top, and sometimes you chose to play left. But remember, this is supposed to be the Nash strategy, the Nash equilibrium. And yet, as you can see in the numbers, with some frequency, the proportions of people trying to play top was sometimes between 60%, 50%, 40%, and so on. And the same for the other players. And the reason is, you read that in the text in the chapter, because there are preferences for prosocial behavior among people, among humans. And one way to represent that, you saw that in the chapter with some explanation using simple indifference curves. If Bala or Anil have some pro-social preferences, that is, they move away from being purely selfish, they would get utility or well-being by improving the outcome of the other players. And therefore, in that particular game, yes, the Nash equilibrium is that they both play Terminator, the exterminator, the pesticide, but it could be the case that you want to move away from that because you like, for example, that the other player makes more money and also you. It could be that if you play Terminator, even if the Bala player wants to play IPC, you would feel bad because you make 4, which is much more than 1, and you don't like extreme inequalities, and therefore you prefer, for example, to go to 3-3. and so on. This that I just said has been proven in the laboratory and with evidence, empirical evidence, that people sometimes, because of altruism and fairness and trust and aversion to inequality, move away from the selfish actions and towards actions that also improve the well-being of others. And let me give you an example here also with a real world experiment. I don't know if you read Freakonomics, and if you read it, you might remember this story. This is the story of this guy who was a retired faculty who happened to set up a business in which he would bake bagels every day in the morning, and he would bring them in these boxes to businesses all around New York, but he didn't have sellers or clerks to control who gets to buy what. He just placed the box in the counter in the cafeteria or the coffee place of the companies. He would leave a basket with the bagels or the donuts, as you can see in the image, and people would drop $1 for each unit that they got. And at the end of the day, he will come back and collect the leftovers and the cash that was inside the box. And he will record every single day for every single business how many bagels he sold. And at the end, he would end up knowing what was the net effective price. So that, for example, if he were to bring 10 bagels and he found $8 in the box and all the bagels were gone, he effectively sold those 10 bagels at 80 cents, but probably meant that two people just got them and didn't leave the money there. So it was an honor-based system. And he collected information on this every day for many years. And here's the graph of the prices that he was collecting, the effective price he was collecting between 1993 all the way to 2004. These are the average prices. And I want to ask you quickly in the poll the following. Which do you think was the effective real price, the average price that he was getting, let's say here in 1993, and how much was the price that he was getting around these low peaks, these low cases in 99 and 2001? Which do you think are those prices in this axis? Between $0 and $1, which was the nominal price. Okay, so if you remember the story, you can tell what you remember, or if you can guess.
Is this the quiz?
No, the quiz is coming up in 1 minute. This is just your guessing. So I'm going to give you 10 more seconds so we have more time for the quiz. 5 seconds. 3, 2, 1, and 0. So it looks like you didn't. I'm going to share the results quickly, and I'm going to show you the truth. And here's the data. The range of values is between 86 cents and 92 cents. That means that this guy was recovering back, or in other words, people were paying back, in the worst case scenario, 86% of the bagels that they were taking from his baskets. Okay? So that, I want you to think of why that was the case. And if you read Freakonomics, the original book, you will find the whole story. There are some papers written about this. But for example, he could explain the variation depending on the organizational climate, the job climate in each of the companies. Or for example, he showed that after 9/11, the honesty just skyrocketed. It went up after 9/11 that hit so hard the New York area. Okay, so I want you to think about that because it has to do with this idea of the social preferences. So now let's going to go to the quiz, and we're going to tell you how's the rules of the game. Very easy. So let me bring here this, and here's the idea. I'm going to open in the quiz each question, and for each question, I am going to open a Zoom poll, and you are going to answer in the poll, each question at a time, okay? So I will run this for 1 minute per question, and it should give you enough. We are going to have 5 questions, okay? So the idea is the following. Let me go with the first option here, with the first quiz question here. And I want you to read the question and the possible options there. Why it's not working? Let me see what's happening here. I want you to be able to see the questions. Okay, again. Here and share, and wait, let me put it here. That's better. Okay, so share. So this is the quiz, and this is going to be the poll for the first question. And the question is the following. This is the first question. Okay.
There's like a black square in front of the.
Yeah, Professor. There's a black box in front of the 1, 2, and the 3. And there we go. Thank you.
That's better.
So 1 minute to answer this. Oops, wait, here.
It's in the way again.
Yeah, I just pulled it out. Okay, 20 more seconds. Okay, 5 seconds, 4, 3, 2, 1. And I'm going to close this. Okay, let's go to the next one. This is the question 2. Twenty more seconds. Ten seconds. Okay, 5, 3, 2, 1. And I'm going to end there. Okay, I'm going to stop there. Okay, let's go to the third question. This is the third question. And 1 minute for this. Thirty seconds. 10 more seconds. 5, 4, okay, 3, 2, 1. Everybody answer. Okay, good. Let's go to the fourth question. Here's the fourth. And this one is going to be, it's going to need a little bit more time. So I'm going to give you 2 minutes for this one. You have 1 more minute. Thirty seconds. Ten. 5, 3, 2, 1, and we're done. And the last one. Here's the last question. And here's the poll. 30 seconds. Ten seconds. 5, 4, 3, 2, 1, and we're done. Okay, great. Now let's pray that I get those data. And Catherine, I'm glad that you made it and you solved your internet problem. I'm happy that you made it for the quiz. Okay, guys, that's it. Right on time, 3:43. So I will download this data and I will send you back the questions and the answers soon, so that you don't worry about the anguish of the quiz. But you can also go back to your notes and make sure that you are clear on how you fared with the quiz and the questions. So stay tuned through Moodle on the plan for next week. We're going to be starting reading chapter 5 in the same core textbook. I'm going to upload the notes, and remember start thinking how you're going to apply these game theory tools to put together a game theory situation that it's applied to your problem of interest in your term paper idea. I still owe you, and I hope that I'm going to send you this soon through Moodle, the feedback on your ideas, so that you put all that together, and that can give you input for your essay that you need to turn in on March 5th, if I am correct. I see here Catherine on the grade. It's in the syllabus. I don't remember exactly the percentages, but it's part of the syllabus there. But it says here in the syllabus, I don't have it open here, but it says quizzes and polls as part of that. I think it's 10% altogether for the grade. Okay, but this is not the only quiz that I'm going to be doing. I'm going to be doing more of these exercises as we go along, along with the participation in the experiments and the like. Okay, but basically the weight of this particular quiz is not that big into the whole grade of the course, so don't worry much about that. I prefer to have many baskets for all the eggs that we have instead of 1 or 2 or 3 baskets. Okay, guys, good to see you. Have a great weekend. Enjoy a little bit of warmer weather you have there, and then I'll see you guys on Tuesday here back again in class. So,
sorry, Professor, I have a question.
Yes.
For essay 1, where is the question, like the essay prompt? Is it on
we covered that in class and in some notes, and I'm going to create the link in Moodle with the instructions. But in the classes, I don't remember if it was Tuesday or Thursday, I covered that, and also I think it's in the class notes. So I'm going to make sure that that is in writing in the slides that I have been uploading to Moodle. Okay, and I will create the paragraph with the instructions on what is it that you're going to be writing. Okay.
Thank you.
And in fact, I'm going to do that right away, so that I'm sure that you have that there between the class notes and the recording of the class and the instructions in the Moodle. Okay.
Thank you, Professor.
Good. Okay.
Good weekend.
So I'll see you guys. Bye bye.
Thank you.